This conference will now be recorded.
Hey guys, can you hear me?
Yeah,
A very good morning.
good morning.
So, just a couple of things before we start the session. Um, Anyone joining today, guys, who are not part of Sunday's demo?
Yes, I am.
Okay, you guys can acknowledge in the chat window too. Anyone who just joined today? Okay, only one. Cool. No worries. So let's introduce ourselves, guys. I would let you introduce yourself once I am done with mine. Okay. So, like most of you must be knowing, who have attended Sunday's demo. My name is Suresh. I have close to 9+ years of experience, guys, where I have been working as a data engineer all the time. Okay, right from the day one of my career, where I started with Hadoop. I mean, I started my career as a Hadoop developer. Then I went on to learn Spark. Then, from past 4.5 years, there is a new term, data engineer. Back then there used to be multiple roles for the same: Hadoop developer, Spark developer, ETL developer, Informatica, so on and so forth. But once cloud came into picture, we are defining whoever works on data, especially creating those ETL pipelines, as data engineer. So, and talking about my Python experience, right? I have been using Python since the day PySpark came into, or PySpark is released. PySpark version of Spark is released. Okay, it's been almost 5 years where I have been working on Python to develop PySpark applications and also ML applications too, using PySpark again. Okay, and I have been training folks on Python since 3 years. Okay, so earlier I was training folks on data engineering from past six and a half years. But when it comes to Python, I have been training students on Python from past 3 years. Okay, so this is a brief introduction about me. Now, would like to hear from you. Okay, so I hope everyone is able to see my screen. Yes, no, maybe. Cool. So this is what I'm expecting, guys. Your name, something like this, and then your name, then your current technology, whatever you are working on. So, for example, testing. Okay, and then your total years of experience. Let's say you are a fresher. You can just ping me. That should do. Okay. So I'll give you a couple of minutes to ping it in the chat window so that I'll have, good understanding on, the audience. Hi Vaishnavi.
Hi, sir.
Hi Lokesh.
Oh,
Hi Hashni. Hi Anushreya. Hi Pratyusha. Hi Nikhil. Hi Sudarshan. Hi Akhilesh. Hi Vaishnavi. Do we have two Vaishnavis? Okay. Hi Satya. It looks like most of you are freshers. Hi Venkat, technology lead, Oracle apps. I would still consider you as a fresher for Python. Cool. Okay. So welcome to the course, guys. Right. So I'm gonna take things slow since most of you are freshers. Okay. Um, there are a couple of things. One thing, you know, ask questions. Ask as many questions as you can. Try to get the things cleared before you leave the session. Okay. And it doesn't mean that you shouldn't get back to us. I mean, you shouldn't get back to us if you have any questions after the session. You can definitely reach out to Career IT folks, sharing your query. Okay, let's say you are doing something and then you are not able to get the output, or maybe you are facing some issues. You can definitely take a screenshot and then write to us. Okay, hi Anusha. Cool. Then let's get started. So yesterday we were discussing a few things, right? You might have to bear with me today as well. Few things will be repetitive and few things will be new. Okay, because most of you might not be present in the session or might not be 100% there in the session. So, you know, today we would consider as day one of our course, right? Let's get started. So we'll start with a simple definition before we jump on to what Python is. What is a program, guys? What is a program?
A set of instructions.
Set of instructions. Yes. Any other answers? Hi Mahesh. Hi Anusha. Any other answers you can think of? Okay. So yes, a program is nothing but set of instructions given to a computer to get the task done. As simple as that. So technically, a program is nothing but set of instructions given to the computer to get the task done. Okay. So how do you give these set of instructions, guys, using a programming language? So how do you give these set of instructions using a programming language, right? So talking about a programming language, we have a lot of programming languages. You know, generally someone coming from a computer science background or IT background, they would learn in this way. They learn C first, followed by C++, then Java, then Python, and then once they come into industry based on the requirement, they might end up writing a Scala code, they might end up writing a C sharp code or PHP or whatever it is, right? So a programming language is one way how you can pass your instructions to the computer, as simple as that. Okay, now there are multiple terminologies which you need to understand this before you actually jump into the programming constructs, right? Because you know, a computer cannot directly take your instructions, right? What are the programming language it could be, there are multiple components that would come into picture, right? So one is compiler. Okay. So before we jump on to the definition of compiler, I hope every one of you are aware that your computer can understand only zeros and ones. Okay. So whatever the instructions you want to give to your computer, you'll have to do it in zeros and ones. Okay. Which would be definitely difficult to us as a programmer or as a human, right? Because we don't understand zeros and ones, correct? That is where this compiler would come into picture. This compiler would convert human readable code, human readable code to machine understandable code. Okay, so here comes one categorization of a programming language, guys. So high level programming language versus low level programming language. Okay, so talking about high level programming languages are the ones which we use to give instructions to the computer, right? For example, Python is a high level programming language, Java is a high level programming language, C is a high level programming language, right? Scala is a high level programming language, so on and so forth. And talking about low level programming languages are understandable by your computer. Okay. So any idea, guys? Some examples of low level programming languages?
Assembly language.
Assembly language, correct? Any other languages you can think of?
Maybe VB,
Machine language.
Visual
Machine
Basic.
language.
Machine language.
Machine language, yes. Okay, so assembly language, machine language, or some old languages like COBOL, they all can come under low-level programming languages, guys. Okay, maybe if you are going through some websites, okay, you might also see another direction into this classification. Which is defined on number of lines you write. Okay, so meaning low-level programming languages, you don't have lot of libraries available, you'll have to write a lot of code. They categorize such type of programming languages to low level programming languages. In that scenario, your C and C++ would also go into low level programming language. Okay, but according to me and according to some websites, right, we consider C, C++ as a mid-level languages, but we don't have such categorization. So I would still keep C, C++ in high-level programming language category. Okay, because in C, C++ you don't have lot of modules available or lot of inbuilt libraries available. You'll have to write code for every small thing. I'll give you a simple example, right? So there is this concept of list or a linked list. Okay, so when you implement the same linked list in Python and Java, it's all about a line of code or maximum two lines of code in Java. Okay, when you talk about C, C++, I don't know how many of you are from a computer science background, but for folks who are from computer science background, we have a subject called data structures. To implement this linked list in C, we will have to write at least 150 to 200 lines of code, which was a nightmare back then. Okay, so in this direction, also sometimes the categorization happens in few websites. Again, this is just a heads up, guys, but generally I don't stick to that definition of high level programming language versus low level programming language. Okay, so for me, high level programming language is human readable and human understandable, whereas low level programming language is a machine language, as simple as that. Okay, I'm just giving you a heads up so that if you are going through any tutorials or any websites, you won't get confused. Okay, so compiler is the component which would convert the high level language which you are giving to the low level programming language which a machine can understand. Okay, now you might ask me, boss, is a compiler component same for all the programming languages? Definitely not. Definitely not. Okay. So for example, if you are writing a Java code, Java will have its own compiler, Java compiler, Java C. Okay, if you are using C programming language, you'll have a C compiler, C++ compiler for C++, and then Python compiler for Python language. Okay, so you might get a question if you have some prior understanding of Python, or maybe if you have attended my demo, boss, you have said Python is an interpreted language. How come compiler comes into picture? Okay, so we'll talk about all those things, but yes, Python will have its own compiler. Every programming language will have its own compiler, guys. As simple as that, which would convert whatever the set of instructions you have given into machine understandable programming language. Okay, are we good so far?
Yeah.
Perfect. Now let's talk about compiled programming languages versus interpreted programming language. Okay, so I'm gonna explain this by taking examples, guys. For example, for compiled programming language, I would take Java, and for interpreted programming language, I would take Python as an example. Okay, so before we actually jump into what happens in the back end, let's try to understand what we get. Okay, so talking about a compiled programming language, right? Um, you know, you will have to write your entire code. Let's say maybe I'm writing a 10-line code. So in compiled programming language, you'll have to write the 10-line code, and then you will have to submit it for compilation. So generally, for any execution of any programming program, you'll have a couple of stages. One is compilation, and second one is execution. Okay, so talking about this compilation and execution, you will have to submit the entire code for compilation. Okay, and once the compilation is done, meaning once your code is converted to machine understandable code, okay, then execution will take place. As simple as that, right? And then talking about interpreted programming language, right? Here as well, compilation will be there, okay, but not in a typical fashion. So basically these two steps, whatever you are seeing here, is done at an instruction level, okay. So for example, I have written 10 lines of Python code. So compilation and execution will be done for the first line of code, for the second line of code, for the third line of code, for the fourth line of code, so on and so forth. Okay, so this is what you get out of interpretation or interpreted programming languages. So you write one line of code, check the output, you write second line of code, check the output, you write third line of code, check the output, so on and so forth. Okay, so what advantage will you get? First thing, you are making it easy to develop. Reason being, you'll have, or you can take complete control on your development activity, because at every step you are checking the output, right? And then easy to debug. Let's say you have written some 100 lines of code, and then maybe you want to, let's say the code you have written is deviating from the functionality you are expecting. So you can go back and easily check where exactly that is missing, right? And that way basically you will be having more control, guys. And now let's talk about disadvantage. What disadvantage do we have using an interpreted programming language? Okay, the first and foremost disadvantage I would say is performance. Reason being, you are actually compiling every single step, I mean every single instruction separately. Okay, so talking about this compiled programming languages, right? You write 100 lines of code, compile 100 lines of code in one go, and then execute it, which will be faster. Talking about interpreted programming language, you write 100 lines of code and execute all the 100 lines of code one by one. When I say execute, compile and execute first line, compile and execute second line, so on and so forth, which is definitely slower. So performance is definitely a concern, guys, when it comes to interpreted programming language. But the advantages it is bringing up, right, is shadowing those disadvantages. Okay, let me take a pause. Are we good?
Yeah.
Yeah.
Yes.
Yep.
Cool. Now moving on to Python features. Okay, so we'll talk about some interesting features here, which are really important for us. First one, Python is an open source. Okay, so what is an open source, guys? Or what is an open source versus what do you call it? What is an open source versus licensed tool?
Open source is free to use, like,
Free to easily available to download and work on
and
it.
licensed version is like we have to purchase and we have to buy the product.
Perfect. That's correct. So I will add another direction to it, guys. So basically, open source, right? So it is free to use. That's the basic definition of an open source tool. But there are other advantages to it too. Say, for example, Venkat feels some functionality is missing. Okay, so he thinks that functionality would be helpful uh, when it comes to connecting Python with Oracle apps. Okay, or maybe dealing some operations or doing some operations with Oracle apps. So he can implement a module by himself, and then he can contribute it to the Python community. As simple as that, so that everyone can use it. Okay, on validation, Venkat will be called as a open source contributor, which is a big tag, guys. Okay, let's say if you have that open source contributor tag in your resume. Okay, so your entry to product companies like Google, Microsoft will be easier. I have seen some companies for some roles, they'll specifically mention they only need open source contributors. Okay, so again, open source contribution is a testimony to your programming skills. Okay, so yes, Python is an open source where everyone can use it for free of cost, and everyone can contribute to it for the growth of this programming language. Okay, and talking about licensed, right? Generally licensed, yes, you will have to pay to use those licensed softwares. Example, your MS Office, Windows. Okay, so you might tell me that, boss, I'm using Windows for free of cost or MS Office for free of cost. So basically, they are called cracked versions. We are not actually using the genuine ones if you are using it for free, but these softwares are licensed softwares, guys. Okay, where a company would maintain these softwares, and what are the enhancements that are needed, right? They, those enhancements are provided by the company in releases. So for example, they have released version 1. Okay, I'm just taking an example, right, with ABC features, and the users, based on users feedback, let's say there are 2 bugs and then maybe 3 enhancements or maybe 3 more additions. So they will add them to the existing code and will release the next version of it, version 2, just like your software updates, guys, Android updates or whatever you can compare to. Okay, so these tools are licensed tools and they are maintained by a company. Okay, Windows and MS Office, which we have taken as example, are maintained by Microsoft, so on and so forth. And we have Venkat here, who is working on Oracle apps. Okay, is maintained by Oracle. It's developed by Oracle and then maintained by Oracle, right? So Python is open source. Okay, and Python is typed programming language. Okay, so I will talk about this point little later. I mean, people who are there in yesterday's session, they might be understanding what a typed programming language is, but I'll get back to this point at a later point of time, guys, because to understand this, you'll have to understand what a variable is and what a data type is. But at a high level, Python can understand the data type of the variable by itself. So you don't really need to tell what data type it is while you are creating a variable. Okay, Python by itself can understand, guys. That's another advantage of Python. Okay, guys, just give me a second. Okay, and third one, Python is interpreted, and you know what an interpreted programming language is. We have spent enough time understanding what exactly is an interpreted language, and then Python is a high-level programming language. Okay, and it has huge library. Okay, huge set of libraries, guys. So um, what is the meaning of the fifth point I have written? So it has so many inbuilt libraries that you might not need to write a lot of code most of the times. You don't need to write a lot of code for most of the times because you have lot of modules available. I will give you a simple example, right? So yesterday I was writing a code to send an email. To send an email. Again, talking about sending an email, right? Um, you might think that it is a pretty straightforward thing where you just need to use some SMTP library or whatever it could be. It's not that easy. I will have to send status of my data loads to that client. Okay, and I'll have to schedule it. I know some of you might not be understanding what I'm talking to, but at least try to understand a high level thing, right? So in order to do that, I mean, if it was some other programming language, I will have to format my email using HTML. I'll have to format my email using HTML. Then there is something called as MIME, okay, to send the multimedia text using SMTP-lib. Okay, so I have to write a lot of code. But talking about Python, right? Python have a simple library called Pretty HTML. Pretty HTML. Okay, so once I have used that module, the code I have written came down to just 4 lines, guys. Just 4 lines. So I don't really have to do that HTML for HTML formatting or whatever it could be, right? I just need to use that and then pass the respective parameters. It has created that content for me. Okay, so just to give you an example, so a lot of complicated tasks can be broken down because of high availability of these libraries. Okay, and then cross-platform. Any idea, guys, what exactly is this cross-platform? Any idea?
Is it like integration you mean to say, cross-platform?
Oh, no, Venkat. So
Like,
platform
or else
refers
it works
to
on various operating systems.
yes. Okay, let's say you have written code on Windows. You can run that code on Linux or Mac as well. Okay, I would say 99% of the time. You might ask me, boss, why is that difference of 1%? Okay, so that 1% is a minimal code change that is required, especially when you are dealing with files. Okay, files is one such example, but there are few cases, right? So pretty simple. Talking about file system, right? Linux uses ext3 file system where the directory structure will be completely different. It will start with root directory. There is this directory called root, and then you'll have subdirectories and directories created, right? And talking about Windows, you have NTFS file system. NTFS file system where we have a different directory structure, C drive, D drive, V drive, so on and so forth, and then we create folders inside it. Folder or directory is pretty much same. In Linux we call them as directory, and in Windows we call it as folder. Okay, So again, there are multiple ways to address the same. We would parameterize them. I would show you how you can do that. Okay. So generally, whenever you are passing file path or whatever it is, we write a parameterized code so that your code will be free from these changes. Okay. But again, since I brought this up, there could be a maximum of 1% change, but it is cross-platform. Whatever the code you are writing, right, it will be or it can be executed in any of the platforms that are available. Okay. And then wide variety of applications, guys. Like I said, Python is everywhere. Okay, that itself is more than enough to explain this point. Okay, you can use Python to develop data engineering applications, data science applications, full stack applications. But again, a heads up, Python, yes, definitely supports full stack applications, but for full stack applications, you know, performance is another important aspect. So generally talking about full stack applications, right, Python is not much used in the industry. I'm not saying not at all used, but not much used. Okay, so for full stack applications, right, people generally go with the Java stack. Okay, I mean, if you want me to compare Java versus Python for full stack development, 80% of the applications are developed using Java and 20% using Python. Okay, but yes, Python do support full stack development. Again, it all depends, right? You want to just develop a lightweight web application, then definitely, Flask will be a better choice. Okay, and yes, you want to develop a desktop application, yeah, Python is here. You want to do some database operations using a programming language, Python supports it. Okay, maybe you want to do something on IoT, Python supports it, right? So Python have grown to a level whenever some new technology or some new tool is coming up, they are making sure that they are offering Python support. The reason being, success of a tool these days is depending on, depending on the support they offer for Python. A simple example is Spark. Spark was as prominent, is not as prominent as today till the PySpark came into picture. Okay, the usage of Spark have been increased leaps and bounds after the component PySpark was introduced. Okay, and that itself shows how Python plays the crucial role, right? And then, this has to be the first point, but I'm bringing it as a last point. Easy to learn and use. Okay, so I don't need to elaborate more on this point because most of you are here for the same reason. Okay, so these are the few features of Python which I wanted to highlight. There is another important feature which I almost forgot: object oriented programming language. Okay, so again, talking about programming languages, right? This brings up another categorization of programming language: procedural versus object oriented programming language. Any idea, guys, what exactly is this? Any idea what is a procedural programming language or an object oriented programming language? Okay, let me explain. Um, at this point in time, you might not be able to understand 100% of it, but at least try to get the high level understanding of this classification, guys. Okay, so talking about procedural language, right? You don't have classes or objects, as simple as that. Okay, you write a simple and plain code and you develop logic starting from line one, and you'll you'll go on implementing the logic while writing that code. As simple as that. So this is what we call as top-down approach. Okay, so procedural programming language is a top-down approach where you start with the line one and you keep on implementing your logic while you go down. Okay. And talking about object-oriented programming language, right here, you will have to do a lot of brainstorming before you actually jump into the solutioning. Okay. So in object-oriented programming language, everything is an object. Everything is a class and an object, as simple as that. Okay. So generally, a class will have properties and functions, guys. Okay, functions in the sense what functions they can do and what properties they can have, and the rest of the operations are done using objects. We create instances of classes and then do the objects. I know it might be sounding like a French and Latin to you at this point in time, but yes, procedural is a simple and easiest way of a programming approach. Okay, so C++ are procedural programming languages. Talking about object-oriented programming language, right? So here you will have, or here everything would revolve around classes and objects. As simple as that. You define class and do the operations using the object. Okay. So again, you might be explicitly doing it, or sometimes implicitly it is taken care of by the programming language itself. Okay. So yes, here this is the reason why we call object-oriented programming language as bottom-up approach. Okay, where you will be doing all the planning first and then create a class and then implement your logic around those classes by creating objects. As simple as that. Okay, so this is bottom-up approach. Okay, examples of object-oriented programming language: C++, Java, and Python. You might ask me, boss, earlier you said C++ is procedural. So C++ is both procedural and object-oriented programming language, guys. Okay, so C++ is the only language which is or which can be implemented both procedurally and using objects or classes, object-oriented programming paradigm. Okay, Python, Java, object-oriented programming languages, pure object-oriented programming languages. Okay, so you'll get a better understanding on few things, whatever we are discussing as we progress in the sessions. Okay, but yes, like I said, object oriented, you'll have classes and objects, as simple as that. Procedural, you don't really need a class and object, you can write a simple and plain code. Okay, are we good so far?
Yeah.
Yeah.
Cool. So we'll talk about our environment, guys. Like I said, first 1 month we'll be using collab environment or collaborative environment. This is a cloud-based Python IDE, I would say. This is a cloud-based Python notebook kind of an IDE. Okay, so there are multiple IDEs which you can use for developing Python applications. Okay, so especially in the current industry, the two um, IDEs which are most widely used are PyCharm and then VS Code. VS Code is nothing but Visual Studio, guys. Visual Studio Code, and then we have another IDE called IntelliJ. IntelliJ IDE. Okay, so these are the few tools which are currently used in the industry for developing Python applications. Okay, again, it all depends on how you are using Python. So these IDEs, right, they are most widely used for application development. Okay, and for data engineering or machine learning applications, we generally use notebook kind of an environment like Jupyter Notebook, Colab, Google Colab. Okay, and we also have something called as Databricks. Databricks is predominantly used for developing data engineering solutions, guys, or data engineering pipelines, I would say. Databricks is a platform though, but it offers a notebook kind of an environment which you can use to write your Python code. Okay, so we will start with Colab, where I'm gonna explain your module 1 and module 2 using Colab, and then we'll slowly move to IDE kind of an environment. Okay, now let me show you the Colab environment. Okay, so to get into Colab environment, right? Colab, this is the link, research.google, not this one. This one you can directly go here, colab.research.google.com. Okay, so this is how your landing page would look like, where you can open your sheets. Okay, now you might ask me, boss, whatever we are creating, where they will get stored? They'll be stored in the Google Drive account which you are using to log in. Okay, one moment. Okay, so either you can click on new notebook here, or you can just cancel it and then file new notebook. There are multiple options available here. You'll get used to them slowly. Just click on this new notebook. Okay, I have already logged in, guys. I have already logged in using my um, Gmail account, right? So if you are not logged in, either in your browser or if you are using an incognito, it will first ask you to sign in. Okay, so you'll have to log in using your Gmail account. All you need to have is a Gmail account to use this collaboratory tool for free. Okay, now I'm just creating a new notebook. Okay, so this is how your notebook would look like. Okay, notebook environment would look like. Okay, so there are few things which you need to understand. Here, connect. If you just click on this, you will see a multiple options here, right? So I'm connecting to the hosted runtime, meaning my computer currently doesn't have Python installed, but I'm still able to run the Python scripts here. The reason being, here it is using the Python which is installed on cloud. Okay, so that is what being referred to as a hosted runtime. If you just hover over it, you will see the configurations. So currently this notebook is connected to Python 3 Google Compute Engine backend. Okay, and the RAM it's providing me is 12.68 GB, and then hard disk it is providing me 107 GB. Okay, and this is for free of cost, guys. You don't need to pay a single penny from your pocket. Okay, so this is where I can develop my code. I can write my code. For example, we'll start with a simple hello world code. Print hello world. Okay, this is as simple as that, right? If it is a Python code or C code or any other code, sorry, if it is a Java code or any other programming language code, you might have to write at least 3 to 4 lines of code to print just hello world. Okay, and to run this, right, either you can click on this play button. Okay, that's one way of doing it, or the keyboard shortcut is control plus enter. You just click on control and then enter. If you are using Mac, it is command plus enter. Okay, and there is another way also to run this code. You click shift and enter, it will run this cell and they will create a new cell. So this is referred to as cell, guys. Whatever you are seeing over here, right, this is a cell. Okay. Are we good so far? Any questions? Okay. So want to add a couple of things before we wrap up today's session. The version which we are going to use is Python 3. Okay. And we will wrap up this session by saying thanks to this guy for giving us such a fantastic programming language. Okay, so he's the guy who invented Python, Guido van Rossum. Okay, so I'm not sure about you, but I would seriously thank him because I have been comfortably using Python from past 5 years. Let me tell you what. In my introduction, I have told you I started my career as a Hadoop developer, right? So in Hadoop, we have something called as MapReduce. Uh, to implement MapReduce applications, you'll have to know Java. So that way, I have worked on Java for almost 3 years, and then I have worked on Scala for 2 years, and from past 4.5 years, it's been Python. Okay, to literally tell you, I'm currently addicted to Python, guys. Seriously. Okay, the only reason is the ease of development, and the second one, availability of libraries. Okay, so these are my two favorite features of Python personally. Okay, so let's take a pause here and we'll continue tomorrow. I think I have covered most of the things which were covered yesterday. Okay, so before we wrap up, any questions for me? Yes, no, maybe.
No.
Cool. Then that's all I have for today, guys. See you tomorrow. Have a good day.
Thank you. You too.
Thank you.
Thank you.
Thank you all.
Thank you.